Good afternoon, everybody. Today we're going to be discussing about how to create a bending schedule based on the previous works we've done before. We didn't do items that has to do with reinforcement because we're going to be doing that in the schedule, in the bending schedule. So there's no point taking off for it there. You can always get your total sum of reinforcement from this schedule and transfer it to your bill or material schedule. So for now, I'm going to be explaining this one I have on my screen. As time goes on, you will understand why I made it this way by having elements description. Now I'll be explaining what each column stands for. The first one, obviously, for numbers, everyone knows what that does. The second one, which is the element column, this is where you write the elements you are working on. If you are working on foundation level, you have to come here and write the foundation. If you're working on superstructures, say columns, superstructures, frames, upper floors, just make sure you insert your elements here such that you can always filter your data. The same thing you have here also. In your foundation works, you have different iron works such as column base, stop columns, and sometimes you have reinforcement in the ground floor slab. So these two columns will help us to filter our data when we need to do that. For instance, if you want to get data for just column base alone, you just filter your data. Okay, you have foundation already on. Just pick only column base. So you can see it took out stop column because we've applied a filter to it. So we can undo that, since for now we won't be doing anything that has to do with filtering of data. But as time goes on in the next class, I'll be explaining how to use those tools to achieve different things. The next column, which is diameter of the bar. This is the sizes, as we all know: 12 mm, 16 mm, 10 mm. In this region, I just used a whole number. There's no point writing 12 mm there because I'm still going to be using the 12 to do some calculations over here. So it's best to leave this as a full whole number. Yeah, the spacing is the distance between two reinforcements. The members, number of members, this column is used to indicate the number of members you have in particular element or description. What I mean is, if I say members of column base, for instance, this column base, how many members do we have of it? If this particular column base here is about 4 feet by 4 feet, and we have 4 of that, that is 4 members. That means you have 4 of that particular size of column base in your drawings. Now the next column is number of bars. Remember here I said we have 4 members of a column base in the foundation, which means here this 12 indicates that we have 12 number of bars inside one member of that column base in the foundation. So the total number of reinforcements of bars rather we have in this particular set of column base is 48. Understand? Or if I should use explanation of if I should use a column as an example, if you have a particular column, you have 4 of the column, 4 members of the same size of column, and you have 12 bars inside each column. That means the total number of bars you'll be having is 48. Then the bend is We all know what bend is now. I didn't explain that one again. Number of bend also, in the cases where you are doing something like column base, for instance, again, if you have a length of 1 meter, you probably will have a bend of 150 mm or 175 or 200, depending on what the structural engineer has specified in his drawings. Okay. Now this column where I wrote A to E, this is where you are going to input your main data. Like if you have a reinforcement which is in a square shape or rectangular shape or a triangular shape, assume you have a cut iron which is in a triangle shape, you have one side as 900, you have the other side as 600, and you have the third side as 700. So what you do is just input the data you have, which is going to equal to the sizes or length of that reinforcement. So the idea of this whole sheet is not for us to start calculating and pressing calculator all the time to get our data. We can always come into this sheet and just input those sizes and their lengths respectively. So you could have reinforcement that has a lot of length, such as those ones they use for inverted beams and all those T-raft kind of foundations, where you have an iron that has a T shape. So just take each side. So the A to E represents each side of the reinforcement. So if you're going to be having like a lintel, for instance, where you have just one straight length, that is, let's say you have a lintel of 1.2 meter, you can come here and write 1.2 meter here, 1.2 meter, 1.2, that's in mm. Then you come here and write the extension, which is 450. Simple. Or you could just write 1650 here directly. Anyone convenient for you to do. Most important, just ensure that your sheet is configured in a way that you don't have to always do the entire calculation yourself. You just need to input data and have your formula logged into another cell, which is going to be the resultant of the entire data you have inputted. Now, going back to this, you can see I multiplied here 4 times 12, which gives us 48 for total number of bars in the entire members. Now the next column is the cut length, which is here I only try to sum up the entire length of the bar. By cut length we mean the total length that the iron bender is going to cut eventually after he has gotten the shape, the desired shape which is supposed to cut the iron to, which includes the total running length of the iron plus the bend. So what I did here was very simple. I added A to E together for, which is the sum K3 to O3 plus the summation of the bend together. If you have two bend, 2 times 150, that's 300. I could have as well just total this and giving it a column here, but still anyhow you want to do it, that's convenient for you, you can always go ahead with that. Then the next column is our total length, which is what I have in this cell is the total length of the iron in the entire number of members. So here it's very easy. The total number of bars multiplied by the total cut length. gives you the total length of reinforcement in that particular member, but those answers are going to be in millimeters. That is why I had to use divide the answer by 1000, so we convert it there from millimeters to meters. Yeah, that's for total length. Now this particular column is where there's sort of a trick. Now the trick here is, because this total length I'm getting here, for this one it might be 12 mm, this might be 10 mm, this might be 8 mm. So how do I differentiate these sizes? Very simple. All I did here was I configured the sheets in a way such that if I input 12 mm here, my result, this total length result is going to appear in under 12 mm column. You can see this one that is 10 mm bar now. If I change it to 12, this answer that's under 10 is going to shift to 12. Okay, let's just make that quick. You can see 12. You can see it has shifted to 12 mm. I change this one to 6 mm for instance. 6 mm. You can see this total length has adjusted to 6 mm. What this does for us is it helps us to sort our data so that we can know the number of 6 mm, number of 8 mm, number of 10 mm reinforcement. So when you're having your bill, it's just to transfer the total length to your bill. So then beneath it you can have the total of each, the entire 6 mm, you can have the total of it down. Then the weight, yeah, you convert it to weight, while in the last column you convert it to ton. So it depends on how you want to do it. If you want to take your total ton to your bill, no problem. If you want to take your weight to your bill, no problem. But with this, you have killed so much time in your work. For those of you who work on site, where you need to make material requisitions, you don't have to always go and start calculating how much reinforcement you have in your column base or column. Just have this data spelled out for you. Then go there and look at what you need. You need column base. Go there, sort your data out, and you know what you'll be needing. You don't have to always do small today, come back tomorrow, do another bit again. You can just have it all in one sheet at the same time. So I think that's all for this. So now let's go into how I configured this sheet. Okay. So this was the sheet we used last for our previous sections. So I'm going to create a new sheet now and name this bending schedule. Anyhow, if you are okay with calling this reinforcement schedule, no problem. There's no big deal in what you want to use to name your sheet, as long as you understand what you want to achieve. So I'll go to the first column and insert the numbers, the elements, why am I getting the spelling wrong? Then description. Third description, what do we have? We Where is that shit again? After the description column, we have the diameter of bar. Bar sizes, anyone call it bar diameter, whatever you so desire. Then you have the spacing. All this should be in please. Then later you can now convert it to meters because it's more convenient to work. When you work with for reinforcement, it gives you accuracy. Then you can now go number of members. Number of bars. Total number. The bend. Number of bend. Then you have the A, B, C to E. A, B, C. Then the cut length. Total length. Okay, I think I should adjust this cells. When you're trying to make yours, you could just anyhow this is convenient for you, just make it big. Doesn't have to look like how my own is. You just understand what you want to achieve and you can always apply a different form of formatting to yours. And this is a very long sheet, so you have to be very careful so you don't delete stuff. Okay, now in my previous sheet I showed to you, I wasn't having total, the sheet I used to explain to you guys the first time. You see I have just bend and number of bend. I didn't have the totals of the bend as I did for totals of the bars. But fine, we could include that in our taking out sheet also. That's no big deal. Just for sake of clarity, let's include that. Total bend. Yeah. Just make this bold. I like it bold, so I think I should make it 10 so I could get more screen space. So what do we do next from here? So here now we'll now try to create our formulas. Like I said earlier, what I explained to you guys earlier. Now I'm going to bring in those formulas. Now we know our total starting from number of bars. This is where we have our first formula. think I need to wrap this up so this data can come down better. Now I can see very clearly. Okay, now the total number of bars is going to equal the number of members times number of bars. So you multiply this column to this column. Capish? Very simple. So for now, I'm just going to drag this down so we can always get a clear view of our screen. I just drag this down here. So you see that if I input anything here, say we have a, okay, let me just input something here. If I say I'm working on frames, description is column. I'm working with 16 mm. You don't need to write the 16 mm, just write it in whole number. Columns don't really have spacing like that, so you don't need to. This column is just irrelevant actually. Why I place this column here is just in case on site there's need for confirmation for the iron benders. This column might be useful to them. But if you deem it's not necessary, you can just take it out. It's doing nothing. It's just to give whoever is looking at this sheet proper information. Because someone could look at this sheet without even looking at the drawing, because you've transferred what you have in the drawings to this sheet. Okay. Like I said, the bar 16, number of bars of members. Say you have like 10 columns in that building, and in each column rather, you have 4 reinforcements, 4 length of reinforcement. That means in total you have 40 lengths. I think that should be clear. Now, assuming we are having a bend, what's happening? Assuming we're having a bend, say at the bottom of the reinforcement, the column, assuming we're having a bend of say 150 mm. Just put the bend 150. Obviously, we know for column, the bend, if there's a bend, it's going to be just one, because it's just one length running, and it's running downwards. It's just going to be one. But if it was a column base, for instance, where you have one side about 4 feet, if you have this bend is going to be 2, because it's bending on both ends of the reinforcement. It's going to be 2. But for column, it's going to be 1. Just understand that. So I've not configured this, so this is going to be equal to 150 mm multiplied by 1. So if I change this to 2, it becomes 2. So for now, I'll leave this as, okay, let's leave it as 2 for the sake of clarity. Then what A, B, C, like I said before, it means this represents different sides of the reinforcement you want to bend. But for column, we all know column is just one full straight length. So if there's a bend, you already put the bend here already. So we just need to go for the straight length. So assuming we are using an height of say 3 meters, the usual height 3 meters. That's all we need, 3 meters. Now, what is going to be our cut length? Our cut length is going to be the total. Our cut length for each bar is going to be the total of A to E plus the bend. plus the bend, that gives us the total cut length. So if you have a 3 meter height for a column and you have the bend at 300 mm, so what this means that the iron bender is going to cut 3.3 meters, which is the summation of A to E plus this. So our cut length is going to equal to our total bend plus this plus B plus C plus D and plus E. Now the reason why I had to add everything up together is just in case you have a different shape of reinforcement. Say you have like maybe at the top of the running length, you have another sort of like a bend at that corner, or there's another extension that goes towards another angle. See, that one is around 200. You can see that the length has increased, but I prefer to write it this way. Sum this entire range and close bracket, enter. The reason why I use this method is because if I include a cell here, for instance, say you have a very large reinforcement that has a lot of sides to it, and you want to introduce new columns here, you need to come here and read formula again, because this already contains the range between K to Q. So you don't need to edit this formula again. Just keep inserting any column you want to insert. So let's delete this. Now the total length, remember this 45 is just for one single bar, and meanwhile we have 40 bar the entire column. So what do? We just go is equal to open brackets, say 40 multiplied by this divided by 1000. So this has to be in brackets meter. So that result has to be in meter. Your cut length could be in meter if you want it to be. You can just divide this by 1000 or leave it in mm, doesn't matter. Anyhow, anyone convenient for you. Oh, now let's give this place a color so it's different from other things. I think I should give this red. Let's go with blue, since we're using blue as our headers. Let's pick this and go with blue. Now there's something else I'm going to do here. While I'm scrolling down, I like to see what's on top here. So I'll have to pin this first row to my screen so I can erase it. Where is that data? No. View free stop row. So you see that I scrolled up, in case you have a bunch of data work to do here, you might miss your headers. These headers are meant to guide you on where to input your data. So once you keep scrolling up or down, this first row is pinned to to the top of your screen, and you can always use it to track wherever you're working. Now, so this is the formula here. I'll drag this formula down also. I'll drag it down also to this point. Come on. So anywhere you have formulas, just drag them down. Just drag them down. Just drag them down. I like to, when I'm working, okay, maybe next class I'll explain how to lock the cells that has formula so that people don't tamper with those cells. But for now, I'm just going to put the cells that has formula in different color so that you know where formula is and you don't go and delete. I would advise you do that when you are working. Just put cells that you know they contain formulas. Put them in, I think, just any color you desire, maybe red, something. Colors with cells with formula. Put them in color red so people don't tamper with those things. You can put this in red also. Nope. Come on, red. Yep. So when you see this, when you know here you have formulas, you can't delete whatever you have in these cells. But for the best places where you're having ordinary cells without the colors, you can always go there and edit. So just when you have a different reinforcement work to do, you can always come here and change the data and you have your results. These cells will produce your result for you. You need to go and start messing with them. But in the next class, I'm going to explain how you could lock this data. So let's assume I'm still working on, okay, I'm going for foundation now. Okay, let me see our frames. Let me go for beams. For beams, you could have stirrups and the main bars. The difference in the two is the sizes of the sizes, the bar sizes. So if you are working in the main running length, you can just, if that is also, let's say it's 12 mm, then what's the number of main bars for your beam? Depends on how you want to take it. If your details show that you have similar beam with similar lengths, you can just use this method and take it in numbers. But if you have your beam whereby you have to look for your guards, how do you do that? So anyhow, just look at how you understand your beam work. Okay, let me just use an example. I think I did a drawing for this tutorial. Let me just use that drawing to explain further. So if you have much understanding, you can know how to manipulate your sheet. But for the sake of tutorial, I'm going to use a drawing I created to give better understanding. Okay, I think it's clear now. Okay, let me use this beam 4. We can see the beam 4, the length is 4800. Now in this case, now you have to work the length yourself between this point to this point to know the total length of reinforcement, the actual length of reinforcement. But for now, just stick to 4,800. But definitely, it's definitely more than 4,800 because there's an extension to the sides. So what do? You go back to your sheet. This is what you want to take off for. You go to your sheet and say beam. The beam number of beam you have. That beam is just one. Members. How many members do you have? You go back to your drawing again. Look at the section. Okay, we are working on 12 bars. Those are the middle ones. So you have 1, 2, 3, 4, 5, 6. You have 6 of them. Number of bars. Then you now go the bend. For this reinforcement now, the bend should be this is 1,200. You should have a very good bend that covers the total height. So let's just look for it. Let's just use a bend around 650. Oh, sorry, it's the middle bars. Oh, this one might really have bend. But let's just say these middle bars here have bend, which is unlikely. Just assuming so we can understand our formulas better. So let's say they have a bend of 450. 2, yeah, it's very 2. Now, what is our length of the reinforcement? Like I said, let's just take the 4/8 like that, but definitely it's going to start from here. So assuming we have 100 here, 100 here, so the 4/8 that's 5,000. So we can add the 5,000 to our data. 5,000. Boom, that's it. You can see now you already have your beam worked out for you directly by just inputting the number of bars you have, the length, and number of members. So if I had a similar beam, like you can see this is beam 4. Okay, look at this formula now. Look at this beam B to C, 36, beam 3 and beam 4. They have the same size. So such beam now, you can just go into your formula and say that has 2 members. You can just come in and change the 2 members. If we're doing the one with 36, and change this to 36 plus 200, which is 4,000. That's for the beam 3 and beam 4, which we now are now working on. Because this has 2 members, each member has 6 bars. You have 12 bars in total with the bend, 2 bends, 900. Then total length is 4,000 plus this. You have this. Now look at this one. In a case like this where you have this 750 extension, when you take the full length from here to here as 4/8 plus 36. If I was working with this ABC, I'll just go to my work and write 4,800, 36 and 750 and I'm done. I just go write the 46, 38 and the 750 for 4/8, A to B, B to C, 36 and 750, the lapping, and I'm done. and I have my answers already. So you can see it's very convenient. You don't have to always start typing, start writing out numbers. Take your time. That's all. Then, okay, that's just to give you an example of how this particular areas work. Now, the other area that where gives me where I said there's a trick on this part, I'm going to write. Okay, on this part, I'm going to be totaling the length below, and I'm going to sort the data according to their sizes. So what do? I can just come here. What's the first size of our reinforcement? We have 6 mm. We can 6 mm. We have 8 mm. We have 10 mm. 12, 16. When we use cap lock, it gives you the different feeling. So I'd rather we use lowercase. Twenty, 25, 32 mm. So if you have other sizes you want to add, you can add it once you understand the formula I want to create here. So what I'm doing here basically is I want to tell Excel that, see, I want to sort this data. We can see that what the formula, we can see these two we've done now. One is 16 mm, one is 12. But we have them on the same line over here. But I want to sort them here. So I have to tell Excel that, I'll tell Excel what to do by telling it, giving it a criteria to work on, to think on. Excel has to think for you how, or rather has to think for Excel and give Excel the command. Now I'm using the if formula again. That if function is very powerful. How do I use it? I'll tell Excel, look, if this particular, I'll tell Excel is equal to if this cell is equal, what am I doing? Sorry, I had a pause, so let's go back. If, use the if function. If so the formula is if, open bracket, always open bracket, it's necessary, if this cell D2 is equal to is equal to 6 mm, just write 6, you put a comma. So you're telling Excel that if that statement is true, what telling Excel to do that is you give Excel first a criteria by saying if that cell is equal to 6 mm, If that is true, do this. But if it is not true, do this. So if it is true, what should it do for you? It should give you the total length of that column base or of that particular cell, which is 180. You click it, comma, you put a comma there for the next statement, which is if that d2 is equal to 6. If it is not true, what should you do? Put 0 as your answer and close brackets, enter. Now you can see, because my bar is not 6 mm, that is why I'm having 0 here. If I change it to 6 mm, you can see the 180 has come in place. So this helps to sort data. So let me change this back to 16. So we're going to do that for every cell across. You don't have to work, you can drag this down too, yes, but let's finish everything and confirm that it works for one particular cell range before now drag it down to the entire cell. So the same formula we used there, we're going to copy it across the next cell. You can just copy the formula then enter. Better still, if I wanted to do this more easy, I'll just put a $sign between. When you put a $sign like this in between this cell, it means you're making reference to that cell. So when you drag the cell down, it does not change. But if you don't put $sign between that D and 2 and you drag it across, you're going to keep changing to D3, D4, D5, D6, which gives us a wrong answer, because our reference cell in this formula is cell D2, where we wrote the sizes of the reinforcement. Because if I decide to put a $sign here, I won't be able to drag it across. If I do that, the cell is going to be making reference to cell D2. Can I give an example? Look at this 6 mm. If I drag this down, you see that the formula here has changed to cell D3 and the result is in R3. Let me click on it. You can see the cell D3 is active and cell R3 is active. But if I use a $sign for this, I won't be able to drag it down because it will still make reference to that cell D2 and R2. So that is the reason why I'm copying the formulas into this cell manually. Enter. Copy. Enter. Copy. Enter. Now let's now rectify the formulas. We said the first one is, now D2 must equal to this, corresponds. The next one, D2 will be 10 mm with 10. The next one, D2 must equals to 12. Next one, d2 must be equal to 16. You can see that it's has given me the answer because that particular diameter bar is 16 mm. So this one must be 20 to have a answer in this sheet, and this must be 25. It's 32. So as long as in a cell you cannot have two okay, I think I need to let me just I want you guys to see clearly. Let me hide the cells. Okay, so because this is 12, this is 16 mm, that is why you have this cell active. If I change this to 25 mm, you can see the results move to 25 mm. If I change to 32 mm, what the fuck? If I change it to 32 mm, but what I work after now is 16 mm. So what's next is we now highlight this entire cell which is given a formula, and we drag it down. So you can see we're all having like zeros. I don't like seeing zeros. It's I don't know, it's just somehow I don't like it personally. So if you don't want to see zeros in your formula, if you don't want to see zero in an empty cell, you could just make this double like this and enter. It's going to put, that means empty. That cell means, that thing I did means empty. So just drag this down. So I can do the same thing for here too. This basically means null. This means don't put anything in the cell. Make it null. No. When you do that, you can drag it down. So basically this is how to run a very good reinforcement schedule. In our next class I will be explaining how to now work with it, because this is just the first part to it. After this one, next class I'll be explaining how to utilize what you've configured. So I can just copy this and drag it down. So very clean and neat. Let me take one more example and do foundation. Colon base. Let me go back to the drawing I created again. Now this is, we have two kind of column base over here. The first column base 900 by 900. So you would have to use your whatever, between here and here, between this point to this point is 900 mm. But we all know you have to deduct the cover. So when you remove, let's assume your cover is just 1 inch. So on both sides, you remove 2 inch, which is 50 mm from 900. So you have 850 as your total length here. So we can go into okay, we have 5 and 200 mm. Okay, 200 bottom, 200 top, then you have 12 mm. Okay, good. So the bar size, what's the bar size here? 12 mm. Spacing is 200. Like I said, that column is relevant to the work we're doing here. Number of members, we have just one member. Abi? No, it's more than one. It's more than one. The first, you have 6 of it. 6. So number of members 6. Number of bars. Now look at these two clearly. One of them has a square side and one has a rectangular shape. I can decide to take this square together in one cell, but for this one I can't do that because they don't have the same length of reinforcement. I'll take this one also and explain to you how you work around this one. So this we have 5. Since it's square, that gives us a total of 10. So just come into this place and number of bars, you have 10. Then the bend, let's use 200 for the bend. Also have 2 bend. Oh, I think I locked I eat some shit here and hide. So we have 200 bend, we have 2. Then to your next data, what is the length? 900 minus 50, that's 850. 850. And that's all, you have your data ready. Boom, just like that. Now you can see because it has already been configured here. Maybe I just inserted my parameters. I already have my data by itself going to where it should belong to. So let me just quickly round this up. It's taking time already. Yeah, I want to create extra rows below. I'll call the first one total length. Total. The second one will be width. But in kilograms. Also width in tons. So what we just do is just going to sum. So you can come here and it's equal to sum from the cell. Just drag it down and enter. So you've done that. In next place, you want to convert it to kg. What do? You have your data, your results here in You have your results here in total length. You want to convert it to kg. What's the formula we use? We use um the diameter of the reinforcement. You raise it to power 2 divided by 162. So yeah, a different way I could do this. I could just write the formula directly into this cell, or I could link it up with no. There's no point linking it up because it will have to change when you change your data. So yeah, we know we're gonna link this to this particular one. So how do we write our formula? Simple. Just gonna say equal to. I would have liked us to do a trick. I can explain. I'll explain that to you later. Because we are working on that 6 column, this will be 6 raised to power 2. You close it. Power 2 divided by 162 times the cell upward. Enter. Then your weight in tons, you divide whatever you have here by 1000. That gives you in tons. Yeah, because we have nothing here, that's why the cells turn out to be 0, 0, 0. So I can I'm going to drag this across because each cell already has a formula. So when I drag this, it's going to correspond with the cell. Only I have to just like edit it again. So I've dragged this down here. But these formulas are not correct because yeah, it has a 6, which is supposed to be 12. So just go and change this formula. This is 10 mm. And this is supposed to be 16. Yeah, that's it. So I would like to format my file so that it looks a little bit nice. This looks too basic sort of. So I could just come. Yeah, I'm just doing what I like with these cells. When you want to do yours, you can do anyhow, anything you want with it. I like, yep, okay. Yeah, I like it this way because of my site. You can make this bold. So whatever, just play with this and have fun. Whatever how you deem it fits, no problem. Mm-hmm. Yep. Yeah. Yeah, see, I left out just this two because they don't contain any data. Yep, yep, yep. So finally, I'm going to be adding a filter button in here. I need a filter button on these three alone. Insert filter. Go to the data tab and where is the filter button? Nope. Okay, insert. Oh boy. Okay, I found the button. At times, Excel can be so crazy that you have to spend time looking for certain kind of tools. So I was looking for the filter button. I'm going to apply a filter tool to these three columns in particular, and I can click on this filter. The reason why I did this was because, okay, let me add one more icon, one more data to this first. I'm still working on foundation, so you can drag this down. I'm still working on column base, you can drag it down. So I can go to the next column. I have one side as 1200, I have 7 of it, and I have two members. So let's go to shape. The bar size is still 12. This one is still 200. Number of members 2. Number of bars 7. The ben is also 200. Number of ben is still 2. Then the one side of it 1200. Let's remove our cover from two sides and remove 25 here, 25 here. There's 1000, 2 minus 100. That's 1. So you can see our result is already computed. But we're not done with this particular column base. We continue to number 5. We are still on foundation. We are still on column base. We are still working with 12 bar. Just repeat these things where necessary. Then now go number of bars still 2. Then we go to where we have differences in the data. The other side we have 900 You have just 5 of that. 5 of that. So you have number of bars, that is 5 units. Same 200. Total bends the same 2. And you have 800. Oh, sorry. There was a mistake. We said the cover was 25 So it will be 2 minus 2 times 25, which is 1150. If you remove 25 from the two sides as cover, so this is supposed to be 1150. While the other one is 900 minus 50, That's 850. So doing that, see that you can see that because I'm done configuring my sheets, I have my answers waiting for me. Let me make this 10 mm just for sake of exploiting the sheet. Let me make this 10. Now we can see our results. You can see that the cell that has 10 mm is now active because there has been a data inputted with the reference to 10 mm. But if you go in and input like 40 mm, which you don't have here, you're not going to have any results here. So if you're working on a work on something that has any sizes of iron that is not here, you will need to include it yourself and copy the formulas to it again, so you don't get your work messed up. Now the last thing I was discussing about is the filter. Now the filter I inserted is, like I said, for people working in the construction industry, or rather people working on site. People working on site, if your boss asks you to bring a material schedule or bending schedule for iron works as regard foundation, if it's a fresh work, and they want to know how many iron they will need to make requisition from the head office, or how many iron they will use to pay subcontractors, you can always come in here and deselect everything, and you have only your foundations alone. You click it alone, and see it brings out for you only the data of your foundation. But the only problem I have with this sort of filtering is that it does not give you the total of this. That means you can see that you have just 10 mm and 12 mm in foundation. It doesn't give you the total, so you can by yourself go in there and just make a quick summation. But in the next class, I'll be teaching you how to use advanced filters to solve that problem. So assuming in foundation you want to know just numbers of 10 mm, click on 10 alone, and okay, and you have your 10 alone showing. So that is the advantages of using filters for your work and sorting your data. If you feel you need to include another sorting criteria, you can do that. Maybe in the case of where you want to sort your column base according to their sizes. You can have foundation, yes, column base. You can have something like subject. You can say subject. Just look for one keyword that is reasonable. You say subject, so you can, if your column, okay, let me clear, I need to clear this filter first. You can say column base. Now in your foundation you have 3 column base, 2 rather. Now you can come here and say the first column base is 900 by 900. This one is 900 by 1200. So just repeat, because these two are the same, they're from the same member. So if you want to sort again, like I said, if it asks you to just bring according to what you want, say okay, I need data for only this particular column base in the foundation, just go there and foundation, okay, column base is there. Then for which bar size, 10 mm alone, they can now go and say okay, you want to see for only 900 by 900 or 900 by 12. Oh, you can see that there's a mistake here. I have one as 901. That's why I'm having 3 filter criteria. But if I clear my filters and correct this to 900 alone, and I go in and filter for foundation alone, and I come here and filter again. You can see now I have just two because I've corrected the error. So my column base for this particular size alone, this is the amount of reinforcement I'll be needing. This is just in length. So you can now go in again and now like convert it to tons. You don't have to always, this way you don't have to always go in and start trying to calculate for one particular aspect. You already have the data here. All you need to do is just go and sort according to how you want your data. That's all. So that's all for today. Yeah, I think I've tried for today. So next class I'll be explaining how to use this particular advanced filter. It is very, 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 very nice. I'll explain how to use slicers. Where are these things? You just come and disappear. Anyway, next class I'm going to explain how to protect your book, how to use slicers, what else? Advanced filtering. Yes, one thing again I forgot. When you are working like this Excel in such manner, when you input data, don't always leave a space within two ranges of cell. If there was a space, imagine there was a space in here, or okay, if I didn't fill this up and I sorted according to foundation, because there's no foundation here, it's just two, it will give me the result for just these two alone. This one will be left out. You can see why you always have to ensure that you fill up, you don't leave any blank spaces, any blank cell. Everything has to be according to the criteria in which Excel can filter your data for you. So what else can I touch now? Okay, I'll explain also how to use slicers in the next class. Yeah, it's a slicer. I'll explain how to use this in the next class too. So this one is going to cover for those tools are also advanced filters tools. Yep. So thank you very much, guys. I really appreciate those who has been supporting one way or the other. See you guys next week again.